We led you on a journey through the beginning of the technology, the very early days of the 2000s, and then walked through how the scientists continued to develop that technology, how some of the very early organizations developed out of SynBerg, which was the Synthetic Biology Engineering Research Center, and how that spilled over through programs like the Biodesign Challenge into places like New York City, where biology had never found its way and was really being driven by student interest. So now you're going to hear about some of those early institutions and people who were responsive enough to what they saw happening to actually establish new programs at schools which never had labs before, and to help grow this burgeoning industry in New York City. So Dan Grishkin has been working with all these people for a number of years, and he's going to tell you all about that.
Thank you, Nancy, and thanks for having me back up. Very quickly, I'm just going to give a little bit more context on who I am. So I run a program called Biodesign Challenge. Whoa. Everyone okay? And I'm going to just show you real quick a little bit about it. So what we do is we work hand in hand with students in universities around the world and high schools now. We mostly work with design schools, but also academic biology programs as well. We partner the students with subject matter experts. Some of them are biologists, some of them are designers, some of them are artists, and under the mentorship of their instructor and these subject matter experts, they break into teams and form projects. At the end of the semester, one team is chosen from each one of the institutions, and they go on to, well, that slide's done. They go on to present on stage at the Museum of Modern Art. Everyone in this room is invited on June 22nd and 23rd to Parsons School of Design and the Museum of Modern Art to see all of these projects. One team goes home with our grand prize, which we call the glass microbe. You can find it on the website. So check out Biodesign Challenge or check out buildsbio.plus, and you'll see the projects. In the last couple of years, as we've been working with, I think this video might be working. Yeah, there we go. In the last couple of years, as we've grown the program, we've started to partner with brands and do kind of mini design sprints with our international community. And so what you're looking at are some images from the projects that we did with Google. So Google wanted to see what the future of hardware might look like if we were to have more sustainable materials in our hardware. And so students and professionals from around the world came together, had a mini sprint with us, and produced all these wild and interesting ideas to basically make Google a more sustainable company. I just want to give you a little sense of what makes this different from maybe what you've seen in other types of programming. I think what makes this community special in general is that we're not just thinking about what we can do in the lab. I sort of think about it on this little matrix. And so the students that we all work with are both, yes, trying to solve problems, but they're also looking at today's industry and solutions that are already out there and trying to find what new problems come up because of them. So both we are looking at problem solving, but we are looking at problem finding. On the other end of the spectrum, or on the other axis, rather, there's sort of two poles here. There's actual problems, like actual technology that exists today that the students are working on, but the students are also doing something quite different in that they're thinking about what might be possible 10 or 15 plus years in the future. And I think because they're both looking at technology today and what might be possible tomorrow, the projects that they end up coming up with, and everyone on this panel will be able to attest to this, end up really leapfrogging what's currently available in technology and start developing projects and developing technologies that are going to solve tomorrow's problems. So that's us in a nutshell. If you want to reach out to me, you're all welcome. Again, June 22nd and 23rd at Parsons School of Design. We also have a gallery show, and you're welcome. So I'm going to pass the baton over. Hang on.
Do we know who's next?
It looks like me by that side.
So yeah, we'll move the clicker down.
It's good on
please,
far side.
yeah, please introduce yourselves.
This one this way? Okay. Hi, everybody. I'm Theanne Shiros. I'm Associate Professor of Science, Material Science, and Sustainability at FIT, a research scientist at Columbia, and proudly a co-founder and the Chief Science Officer at Werewolf, which you'll hear from later. Oh, that was supposed to be up. I've been, for many years, building a research program together with partners at Columbia University, building with biology. So building regenerative materials with biology that have equivalent performance or higher performance than their synthetic analogs and can easily be recycled or reintegrated or biodegraded for a full fade into living systems at the end of their life and provide nutrients for healthy ecosystems, which are important climate regulators. And something that really struck me when I began as a faculty member at FIT is that we all know the take, make, waste model of the linear economy has catalyzed an anthropogenic tipping point, potentially severe and irreversible climate impacts and impacts on biodiversity and health. But what is maybe less known is that the textile industry, singularly, is a critical driver of this threshold. And there's many opportunities to build with biology. So the opportunity to create high-performance regenerative materials from living cells, either tailored at the genetic level or through green chemistry, has enormous opportunity to create high-performance regenerative textiles for a range of applications defined by rapid renewability, high performance, natural soil biodegradability, together with Helen Liu, who is a leader in tissue cell engineering and engineering biofibers for regenerative limbs and regenerative medicines, we kind of found this amazing intersection. And over the last few years, we've worked with our students and combined the incredible design and fabrication skills of FIT students with the analytical skills of Columbia engineering students to do, this sort of petri dish to runway. So nano, micro, macro scale characterization of what starts as a biomaterial and becomes a product. But what's very important to us is building a foundry of standardized materials where we have materials characterized for new materials. We have transparency to communicate to brands and investors. And we also have a table of sustainability criteria and that can be tabulated. So this is something that's central to our academic platform. The Biodesign Challenge has been an amazing conduit for students to enter this pipeline. So regenerative materials from the ocean. Aaron Nesser is here in 2016, the inaugural Biodesign Challenge. They formed AlgaeNet, and he can tell you more about going from an extruded fiber and a hand-knit tank to a Series A. What about regenerative materials from microbes? What you're looking at here is a time lapse of Xylem bacteria that are fermenting sugars from diverse waste streams. We have 2 beakers with 2 different waste streams into pure nanocellulose, which can be purified and processed into materials and textiles from everything for electronics, printable electronics, flexible electronics, leathers, textiles, wound dressings, artificial ligaments. And so in 2017, it's a real good jumper. In 2017, so my students had the chance, and I think something incredible about the Biodesign Challenge is there's no pressure. It's you speculate how you could do things better. And so it kind of it removes a lot of the anxiety for non-traditional science students to enter into this space. And 3 students, Team Grow a Pair, grew a pair. They had the courage to grow a pair, and they used bacteria and waste streams to have a mycelium-based baby moccasin, which they're so prehistoric looking, but they're still close to my heart. And then we built up to, they used traditional brain tanning techniques, paleo-inspired pre-industrial techniques as a green chemistry processing route. 2018, came Wearable, very close to my heart. Chui Lian Li, Valentina Gomez, Morgana Katterman moved between FIT, Columbia Engineering Labs, and Binomica Labs with every, they went to every lab they could get into, and they made their first prototypes of fibers with inherent color and performance provided by engineered protein structure. You'll hear more from Chui again at 3 o'clock. Okay, so something like really critical is that biofabrication is an amazing tool, but still we need the impact on making a circular economy is really contingent upon development of innovative green processing strategies. And this is a big challenge the industry faces. We see this with the bioleathers, we see it with the fibers. They all have a caveat. Either they're coated with polyurethane or they coat a polyester fabric, and the perfect is the enemy of the good. I'm super inspired by all the innovations, but we currently don't have a commercially viable option that meets true sustainability criteria for regeneration. So that would be low carbon footprint, low toxicity processing, and biodegradation by and non-toxicity to microorganisms in natural environments. And so something we tried to work with is we took that bacterial nanocellulose that I showed you, and we used paleo-inspired tanning techniques. The brain is a really traditional, brains and organs are a really traditional way of tanning leathers, and they have a hydrophobic group and a hydrophilic group, and cellulose has a bunch of OH groups, and maybe they'll get together and modulate the cross-linking, and they did. And we saw that not only is green better for the environment, but it's better for material performance. There was a tripling of strength and flexibility and a stabilization of mechanical properties so that toughness, a reflection of both strength and ductility, was now comparable to leather, but we had natural soil biodegradability. We did this through a biophosphorization route through the lecithin, and what we saw is when we exposed this to over 3,000 degree Fahrenheit flame, did not ignite. Now, cellulose is, what you burn when you go camping, right? It's basically very, very flammable. But the unique nanostructured fiber assembly and the layer by layer structure enhanced by the phosphorization treatment through the lecithin tanning redirected the combustion pathway from combusting cellulose into levoglucosan, but instead went to insulating char. So when you remove the flame and you pull the char, so it doesn't ignite, I held the flame until it absolutely charred over, removed it, dusted off the char, and the material was completely intact. This isn't really important. We think of like waterproofing PFAS, but flame retardants are really toxic chemicals. So this is an opportunity to displace some of those toxic chemicals. Well, we know color. Color is vital to the commercial success of a product. Really fast clicker. All right, so dyes and finishing, 20% of global wastewater, 15 to 20% of a product. We actually built in natural color, either directly through biosynthesis or through natural dyes post-processing, and took this all the way to a product. So in 2020, I was paired up with Public School through the UN Office of Partnerships, and they designed this sneaker. And this is the first fully compostable, entirely nanocellulose sneaker other than the cork sole. But a big part of this is standards, right? Is it better? So we have done thorough life cycle assessment to compare the environmental performance, and we found that we found that the biggest impact for our microbial bioleather, although 1,000 times lower toxicity than chrome tanned leather, was sugar, right? Sugar, industrial produced sugar has carcinogenics, hormonally active agents are released during the processing. So we used waste valorization for feedstocks as well as obtained nanocellulose as food byproduct. And we saw up to an entire order of magnitude lower performance, lower environmental impact than conventional analogs, and a 97% lower carbon footprint than cotton or synthetic leather. So we were really happy to be able to share these results. They were published in Environmental Science Advances. You can see the cover on the bottom right. And so we were really, really excited about this. This clicker is going nuts. It's not me, I'm just clicking once. But anyway, so a lot of people were excited about this. The sneakers have exhibited internationally. They're currently on exhibit at the Montreal Museum of Fine Arts. Fast Company recognized the innovation as one of the best material design innovations of 2021, and it's been featured on Netflix and CNN and a number of shows you can check out. So we're really excited about creating, a demonstration of this platform where we can really build with biology and look to nature's processing strategies, whether it be through enzymes or bio-based cross-linking strategies, to have high-performance materials that are fully recyclable or regenerative at the end of their useful life. Thank you.
So my name's Jean Ford. My name's Jean Ford-Risher. I'm an industrial designer, and I teach in the industrial design department at Pratt. We're in a much more rudimentary state than Theanne's work. The biggest question I get asked is, why should industrial designers learn about the life sciences? And I'm here to say that the industrial design has completely embraced the social sciences. We are completely training students to be empathetic to the user's needs. We're very conscious of human need. What we're not so conscious of is the consequences that happen in terms of when we are supplying human need often. So I contend that the industrial designers have to embrace the life sciences because they have to understand both the consequences of how we are actually producing products now, and they can, and as Theanne thoroughly highlighted, the incredible opportunities that biotech have for product development going forward. So I'm just going to show you a little bit of how, there's a little bit of two processes that I work with students. One is a more strategic way. So this is a design studio, so we'll introduce biomimicry, biodesign, and circular design as strategies that they can apply to their design process. I always say biomimicry is learning from nature, biodesign's working with nature, and circular design is acting like nature. And I'm just going to highlight a couple projects. The one on your left is Sophia Hahn, and she was really inspired by pine cones, did a lot of biomimonic research, created a composite that's actually reactive to water, and the proposal is that she would create a vessel that would have a breathing lid. But you can imagine that those applications are much broader than just a container. You could use it on architecture anytime you needed to evacuate moisture. The middle project is Jessie Mang, and it's a speculative project on the future of water quality in Long Island. I think these projects are really important in design studio for students to be able to have an ability to have an opinion about what they're learning in terms of the consequences about industrial production. So she proposes in 2040 we will actually have this prosthetic that allows us to drink polluted water. And then the one on your right is Natalie Graff, and she was really interested in bringing the garden into the kitchen, found moss through that process, and then got very involved and engaged in the photovoltaic properties of moss. Did some really innovative things with the growing medium of the moss. She can get, this is right off the presses from this semester, she can get about a volt out of this small construction. And so it's that idea that at scale, or that you have this ambient energy available to you in the house. So those are kind of like how I might bring the process into design studio. And then the next slide is just really, this is perfect, this is kind of like in the wheelhouse of Pratt. Pratt really, we love to work with our hands. We have a very rudimentary ability to work in this space, but we just, we employ kitchen chemistries, which are just the available biopolymers. We use mycelium. We do work with scobies. We were also thinking about brains and tanning the SCOBY, right? We are, what am I trying to say? Students invent their own recipes. They generally create composites. They often invent their own manufacturing techniques, like ways of drying it or stretching it, understanding the innate qualities of the material. And I just want to point you to one image on the page. On the upper right is a lamp created by a student named Sylvia Chen during the pandemic in 2020. She created this bioplastic with two polymers and grass clippings. It's about this big. It really has a lovely green. And I just ran into her just this last week, and the thing is really stable, which is super exciting for me because we have that longevity of material. Still has beautiful color. So it's really exciting, and it's very exciting for them to understand that they can do something in their studios that has permanence. And then the last thing I just want to talk about is driven from the material research. And I think Theanne pointed it out too, is that the one thing that industrial designers are always kind of navigating is this world between processing and performance. right? And where the demand is. And typically, you know, all of our sort of plastic products would be all the way at the end of that scale, would be basically a waste, right? But working with raw material substances, like they're reasonably processed, but if you're working with a chitosan powder, you can do both ways on that linear line, right? You can go up and you can look the way back to resources. For students, that's really powerful because they understand now, like, oh, it comes from someplace. But as they're doing that research, they start to look at waste streams and they start to think like, oh, that's a really interesting waste stream. Maybe I could bring that in as a composite into a plastic, or maybe I can swap out that polymer for that polymer that's actually a wasted polymer. But they can also go the other way on that line, right? So they can start to identify, instead of saying like every plastic product has to be comprised of certain materiality that will live forever and be dumped in a dump or incinerated, they can start to see where a just-in-time material might fit in terms of the column of like human need, which is really interesting. And it's an interesting way for students to kind of open up understanding where things come from and where they can go and how they might plan for that. So I have two projects that I'm just really quickly going to talk about. The one is a fishing lure. This was also done during the pandemic. The student was in Turkey. He was in a fishing village, fishing a lot, losing a lot of lures, I understand. And we were doing this material research in his kitchen because that's what we could do during the pandemic. And he was like, oh, I think I have some material that has some durability. It's really exciting. And he started adding some things for scent. We were able to do some basic water tests that, you can just prove out like, okay, it will still be constituted in 24 hours, which is exciting. And he was able to cast it. He cast the part. He was able to cast with the lure for about 5 casts until he lost it. But his whole point was that you lose plastic lures all the time. So that was a really powerful impact. And it's just kind of bringing that material in at a place where it's just enough, right? It's doing what it just needs to do, not more, right? And then the other project is Ricky Lai, and we were foaming chitosan foams in studio, and she got really excited about it. Started adding aggregates, started trying to figure out what this material might be. And her proposal ended up being like a sponge that you would wash your dishes with that would disappear after 3 or 4 washes. And the idea is that you don't need the sponge anymore and you don't need the plastic bottle for the soap. So I'm going to wrap up from here. But these processes can really open the dialogue for students and also give them an opportunity of understanding where biotech can solve really critical problems that have been very difficult for us to solve and performance problems. That's all I have to say. Thank you for your time, and that's what we're doing at Brett.
Whatever it says, right?
I think it's me. Yeah, hi, my name is Alison Mears. I'm an associate professor of architecture at Parsons School of Design, and I'm co-director of the Healthy Materials Lab at Parsons. And we're going to go up in scale here from very smaller kinds of objects to really thinking about the impact of how we could transform our built environments to be healthier. And one of the things that we discover in our work, construction, architecture, building is a very conservative area. It's also incredibly large scales of production and materials use. And most of the products that we use in the built environment are fossil fuel-based and incredibly toxic for us. It's an unregulated space that causes us to have a bunch of different health issues, adverse health issues, because of our interaction with this space. And so we look in our work for alternatives to common building products that are able to be installed into construction practices and scaled in a way that makes sense. Mostly we're defaulting to plant and mineral-based products in development because in this context, they become more benign than all of the other options that are fossil fuel-based. So we begin with this really simple system, and when we look at a typical residential wall section, this is the way that a lot of the US houses are built, and it's composed of a structural timber frame that is full of flame retardants. It's foam insulations that are also full of fossil fuels, incredibly bad for us as they break down with our environments, and those particulate matter goes into the spaces. So all of the elements of that wall system, we're looking to switch out and replace with truly healthy, circular, sustainable products that will, instead of making us sick, they'll actually benign and be beneficial to us. So we've been focusing on, as I said, plant, in this case, agricultural based products. We've been looking at industrial lime for the last industrial hemp for the last 4 or 5 years. It has a number of really interesting properties. It's extremely beneficial to the soil, and it's one of the raw materials for any number of different new products. In our case, we're looking at the stem, the woody stem, the hurd from that, combining it with processed lime and water to create a new matrix that we use within a residential wall. A lot of our work is both based within the context of academia, but it's also focusing on practice and how we can change the design and architectural practice of folks in our industry, working with research assistants to assist us. This is and also collaboration. We're working in a lot of collaborative contexts. Our focus is on affordability and particularly affordable housing. This is a project in a post-industrial city, Newcastle, Pennsylvania, a collaboration with Don Services, and it's looking at a renovation of an existing wood frame house. The US is full of decaying housing, abandoned houses, and this is a way to retrofit a house using a benign insulation material that also protects the wood frame from, it reduces flammability of that wood frame, and is something that is naturally grown and naturally produced. And you'll see that at the end of this project, we're looking at really establishing, we did the design for the renovation, then we also specified all of the interior products, which is the space we occupy, all of those products that we interact with, and did the necessary particulate and other chemical testing to establish that the space was actually much healthier than a traditionally created space. And then I thought there was a little video here, but maybe there's not. Yeah, so it's not just hemp and lime. It is also a bunch of other materials, but the video may not work. Let's see. But I can just tell you, similarly here to my colleagues, we're looking at mycelium, saw some great mycelium projects this morning at school, cork, a bunch of benign plant-based finishes. Often the simplest things like paints and finishes are the most toxic in our environments, so we're looking to replace those. And in that process, create new economies and reduce embodied carbon and all of those good things that we have also spoken about. So we'll go from that video, unfortunately, to the way we see making change within our space is really to create any number of resources and education and tools to help not only students but practitioners adopt new practices. And so we've created online programming. We have a podcast you could check out. It's called Trace Materials. It looks at plastics and hemp and other kinds of materials, single materials. We have a website that has a lot of resources, including materials collections that we've evaluated in terms of transparency and harmonized chemical ingredients and reducing that toxic content. And we also just published a new book in February, our first book, Material Health.
Congratulations.
I know, it's very exciting. Thank you.
Okay, hi, I'm Dr. Mitchell Joachim. I'm an architect and urban designer here in Brooklyn, New York, and super glad to come all the way to Industry City and have a conversation. I know many of you, and it's great to see you guys and have this talk. So I'm going to briefly say what we've been up to. We run a 501c3 nonprofit that looks at this particular issue, which is unbelievable, rampant, nonstop extinction in biodiversity. So that's roughly every 9 minutes or 14 minutes, depending on how you count mammalian life on this planet, we lose another creature forever. That's every insect, bird, coral, you name it. So as an architectural and urban design group, we switched our mission to be thinking about this problem specifically. How do you do that? Well, we've sort of recalibrated our projects to take on new clients, and those clients are anything from salamanders to crickets to E. coli to mushrooms. They do not pay very well, and they often die on us, so it's a reality. But we call this kind of work trans-species design. So we're designing systems using light, air, gravity, food, for individual creatures so that they have a chance to jumpstart their populations. This is one of examples of our modular facade systems that incorporate jute with chitosan and look at different creatures in a local food web, and that gets put onto a facade system. We also look holistically at the city itself and think about how could it be socio-ecological? How can we care for other things beyond the needs of humans? We are in the Anthropocene, I get it, but let's start designing for biodiversity. So here's a view of 42nd Street where we get rid of cars and traffic, replace that with trackless trains. We've got a riparian corridor that goes through the center, teeming with aqueous life. We create a grand civic space that privileges walking or pedestrians, and then we skin the surfaces of buildings with photovoltaics, vertical access wind turbines, vertical farms, anything that adds to air quality or food, and create a polemic. This is not utopian vision. It's just a point of argumentation to get us to a greener city. We need these kinds of drawings so all of us could take part of it on an egalitarian-like level and come up with our own variants on this design. Other things we're doing, this was for TED, the final countdown. We created an egg-like structure called the Anti-Extinction Library. It cryogenically preserves a species on the edge of life, something that's going to disappear within 7 years. In this case, it's a salamander. And then this egg slowly decays. Inside there is fertilized eggs and the extended phenotype, all the things you would need in a biotope to keep that species alive. And it's not going to save the population, but what it will do is people will walk up to that egg, if they're curious, and they'll say, what's this about? Oh my God, this creature's disappearing. Maybe I could do something about that. Most likely it comes down to voting for something like the Green New Deal or anything that deals with the environment in cities. Other projects we've been working on for a long time, like so many of my colleagues here, mycelium and acetobacter. Here we're growing furniture in a lab. This one's now 11 years old, but it's a chair that's combining plyboo into mycelium. It's got, it's a triply curved surface and it's lasted a long time, and it's a chair that disappears into a garden, feeds thousands of other forms of life, unlike these chairs, which will end up in a landfill and contribute to possibly almost nothing. Other things we're doing are looking at mealworms. So here we created a farm for mealworms, and this was done in Camden, New Jersey with the Bloomberg Foundation. We get a lot of grants from big foundations. Here the mealworms eat styrofoam. Then they kind of poop it out into frass. Then they re-eat the styrofoam, goes through their enzymatic system, and they produce garden mulch. They then turn into darkling beetles, which get eaten by all other kinds of creatures, thus increasing biodiversity. And people there in Camden get to realize they can upcycle their styrofoam e-waste by donating it to this biodigester machine. So it's kind of fun to see people do that. Other things we're working on is architecture that's truly organic. So I see there's this book on Zaha Hadid. I love Zaha. If you don't know who she is, you should. Wicked, organic-like shapes, but they're just that. They're mimicking shapes in nature. It isn't nature, well put. And so what we do is we grow homes from actual living plant matter. So we're growing willows into clusters that fit into a geometry, folded over parametrically made scaffolds, and we grow homes from trees in situ on a site. We're doing this one in upstate New York next to Storm King. It will be released in August. I can't wait to show the planet. It's working mostly. So it's a very hard thing to do. Since my time at MIT, it's been 16 years, and I can't wait to have this thing showing. So that's that project. Other things we're looking at is food in cities. So we eat too many cows, pigs, chicken, lamb. That's crazy. In 2013, the United Nations had asked in a report, can Europeans and Americans especially start to eat insects as an alternate form of protein. So we created this project, which is the insect shelter and farm. Each one of those chambers will produce a bag of chirp chips every 6 weeks or so. We treat them like sentient beings because they are. They get big and fat, eat lots of great food, lime rinds, apple cores, orange peels. We work with Michelin-rated chefs. Then they die of old age, assumingly happy, having tons of sex, producing lots of babies, making as many crickets as possible. They're then harvested and milled into a flour. That flour is a great thing to eat because most of us won't eat legs and wings and hairy bits, but we will eat bagels, bonbons, or pasta made from cricket flour. So that's this project. This is showing you the crickets and the biotope chambers that they're inside, and actually the cricket sex pods that are also part of this project, which is a fun thing to design. And then there's one or two projects at the end here is we're looking at, this is called plug-in ecology. The urban farm pod, it's a flat pack system that's parametrically controlled. You can assemble it to sizes anywhere from 18 feet to 4 feet. It's part cabin, part furniture, part farm. It gives you an understanding of where your food comes from. So you go from pasture to plate with your farm pod. It does cellular agronomy. You can grow all types of high yield crops. So you wouldn't do corn or wheat. We've got Ohio and Iowa to do that, but it's things like arugula, mints, different herbs and spices, wheatgrass grows inside this thing, and you put it in your food, and you have a relationship between your food, where it comes from, and growing it. There's even an app to tell you when some of these things are ripe, especially spirulina. And then finally, the last project we've been working on is looking at the monarch butterfly, which when we started, according to the U.S. Fish and Wildlife Service, was an at-risk species. It was very hard to count butterflies. About 9 months ago, they are officially listed as an endangered species. So my kids, your kids, we won't see monarch butterflies most likely on Earth anymore, at least where we'll be able to find them. Around 90 million of them disappear almost every year. That's the rough count. It has to do with habitat loss and milkweed. They need milkweed to lay their eggs, and their chrysalis stage is involved with that. So we designed a building in and around milkweed and the life cycle of our client, in this case, the monarch butterfly. This is in Lolita here in New York. It's a sanctuary for these butterflies. We got another grant for the American Museum of Natural History, which just opened, to rethink their butterfly feeders, which is this system here for laying eggs and drinking. Everything is kind of fun with the butterflies, but this system is a fully engineered 2-ton facade installed at the Smithsonian Cooper Hewitt that looks at an architecture designed for increasing biodiversity, especially around the monarch butterfly. It's semi-porous, so they get to go in and out. When you look out the window of this building, you see a garden or a vertical meadow teeming with life. The butterflies in there get a chance to jumpstart their life, and you see all the other plants and creatures in and around them that make up that food web for the monarchs themselves. Again, it will not save the monarch butterfly, but it will communicate to the public that perhaps we should do something, because losing a beautiful creature like that would be unacceptable. Thank you very much. It's my work, and I guess we're going to have a talk.
Well, thank you everyone for your presentations. I want to take us a little bit back. Obviously, these ideas didn't just appear fully formed. You had to go through your own experiences to arrive at projects like these. And I just want to get a little bit of a sense for this audience. How does, for example, a physicist end up doing this type of work, or an architect end up designing for other species, and so on and so forth? Can you just kind of give us a little origin story for each of you? And I'll start from the beginning. Thean, why don't you kick it off?
Oh dear. So an art historian who became a physicist who became whatever this is. From a research point of view, I went into science because I was really interested I was fascinated by nature, and I really wanted to work on climate issues. And I had lived in a number of neighborhoods. I'm from New York. I'd lived in a number of neighborhoods, and food deserts and the extreme effects of the linear economy that disproportionately affect communities of color and women and children and the elderly. It's right here. Like, you can go 10 blocks, and you're like, oh, here's like extreme impacts of a food desert, of bad water, of not, et cetera, et cetera. So I was always I grew up in that dissonance, I think, that space. So I wanted to work on renewable energy. And so I went on to do a PhD in physics with a focus on renewable energy technology and fuel cells. And fast forward through Stanford to Columbia to organic solar cells and nanomaterials. And there was a call at FIT for the future faculty for sustainability and chemical physics. And I thought it was really interesting for two reasons. I'd been thinking about regenerative energy systems and materials to make that technology to convert energy. But I hadn't been really thinking so much about the everyday materials in our sneakers, in our clothes. And I think that was really appealing to me also because teaching science to non-traditional science students, when I was a non-traditional science student going in there post-undergraduate degree, sort of leaving crying in the sea of, male engineers that wouldn't talk to me. Love men, no worry, no problem there. But just saying, that's how it was. And, no one looks like, you're sort of odd man out. You really feel like you're socially conditioned to believe you're not good at this. And I was like, it would be really interesting to pull some, dismantle those perceived barriers about what young people can do, especially underrepresented young people in science and technology. So that was really appealing to me. So I went back to FIT and I was like, that's how these kids are like how I was at this age when I wanted to do more but didn't know how to do it. And then I think, at FIT, I tapped into the huge climate and toxicity impacts of fashion. And it started for me as a way to sort of break down anxiety about science, kind of these products we make, they're like cultural ambassadors of a paradigm shift from fast fashion to a culture of sustainability. So you have to do all this science, but I think it took away the pressure of doing science for art and design students. And it just flourished, and it was like a contagion of ideas where it was now a space where sustainability isn't what you can't have. It's all the things you can never have imagined we could have if you collaborate with nature and across disciplines.
Thank you. Yeah, Thean here is like a one-woman incubator for new companies. It's been incredible to see. I guess I'll ask the same question, Jean. Why don't you take it away? How did you end up doing this type of work? Because it doesn't look like anything in a traditional design department that I've ever seen.
Yeah, I think ever since I was studying industrial design, I think I was always sort of concerned about materiality and just wastefulness. And unfortunately, I've always sort of associated my own profession along those lines, that we sort of encourage it. And then probably 20 years ago, when there was a conversation more about sustainability, I was all on board with that. And I guess I just felt like it wasn't enough. I guess it just didn't go deeply enough. And so I realized that I had to educate myself a little bit more beyond just sort of this idea that you can spec a better material or do something a little bit better. And then I think just that kind of opened up a whole world of everything I had to learn. And then once I learned it, and then it was only this week when I had to put this presentation together that I actually figured out why I think it's really interesting and where those conversation points are with students. Because when you're working in this space, they can actually make material things that are physical, but it also propels them conceptually to think about what their role is as designers, how they can mitigate harm earlier, right? Because that was nothing we were really talking about in design school. I went to school during the days of design for obsolescence, right? So yeah, that's pretty much what it was. It was just the drive of wanting to educate myself more, finding out things more, finding more, finding projects that were listed online, then connecting with the Biodesign Challenge. I think I had a team in 2017. And then just sort of participating on that level, just the educate, it's just every time I engage, it's I get more education. And then as I get more educated, I can bring that back. So I think as I've gotten better, I think I can talk about it better to my students, right? And then I feel like I'm training them better. And I'm training them to go out into the world and to learn more and to participate in this kind of growing economy, which is really exciting, which I don't think we in my department, thinking about biotech is it makes people's eyes kind of roll back in their heads because they're like, what do we have to do with something that's microscopic? So that sense of scale and the sense of where we are as a practitioner, where we can impose ourselves, has been a really interesting path as well, to kind of like give students that agency to be able to like put themselves on a path that's a lot more positive than, than it had been previously. So that's kind of where I'm coming from.
Allison, I'll ask a similar question. You're looking at building materials and architecture. When did you find a shift in your career when you decided, hey, this is where I want to lead my profession, this is what I want to do, and this is what I want to instill in my students, and then, of course, through them onto the world?
Yeah, no, I didn't want to do this at all. And for a long time in my academic career, I used to call myself a recovering architect, and I really didn't like the direction architecture was in the 2000s, early 2010s, when it was really very formalistic and removed from the kind of experience, the personal experience of a building and space. But my work was kind of focused in community, a lot of community work of underserved communities all over the country. And for me, it was that buildings could be a vehicle for occupation and a way for residents, for community leaders and folks to make change within their own environments. So I really was interested in that kind of space. Architecture could have meaning. And then I was brought into this group of people in New York City, and it was led by Amanda Kaminsky, do you know her, from Durst. And they were really looking at building materials, and these like 3 categories of building materials. It was gypsum board, flame retardants and insulation, and concrete, right? It's really pretty prosaic products. And they all have fundamental problems. Why do we have insulation with flame retardants in our buildings? Why are we, building with concrete that's unsustainable? Why is this kind of endemic to building products that they are all so toxic? And for me, this was like, well, why don't I know about this? And this seems to be a problem. And now I have to pick up chemistry as something that I have to understand, because that's the problem, synthetic chemicals that are petrochemically based. And so it felt like it was an urgent issue. It felt like, and it still feels as an understood, as an issue that is not understood typically, that was surrounded mostly in environments where the walls are painted with plastic paints, and it's like we've enclosed ourselves in Glad wrap, right? It's really a problem. Anyway, so with that kind of challenge and that red flag, we started the lab with a grant from a foundation, and we've been tackling this problem. How can we educate? How can we communicate? How can we create resources to make change? Yeah.
Mitch, I believe you were hatched fully formed. When I met Mitch, it was in their first days of GenSpace. You sort of allowed GenSpace to, or you and Al and the people on the 7th floor of 33 Flatbush allowed us to exist in your realm, and it was very much felt like your realm at the time.
There was Al, it was the realm above.
Right,
yeah.
right. There was God, and then, yeah, exactly, and then deities, and then there was us. So I can't even imagine how you came to your ideas, but when was a transformative period for you? When did it start?
Well, with you guys in GenSpace was a big shift for us, absolutely. And Oliver, my roommate at Harvard, was big influence. I mean, he used to drink a lot of wine and talk about modifying spiders that could build architecture, and go back to his work at the Harvard Medical School. And I just don't know what came over him. But I do this work because I got 3 kids. I got 3 daughters, 7, 9, and 14, and they give me a lot of shit, as they should. And I guess I brought them up that way. They think the world is going to crap and we need to do something about it. And my father, who was a hero in my life, is a Jewish guy from Queens, crazy, but he was the opposite of me, and I grew up fighting with him. He was a Korean War veteran, injured, staunch Republican, freaking loved Ronald Reagan, moved to Boca Raton, and insisted that all the greenery around his retirement home was good for the environment, and he wanted to ignore all the fuel it takes for that grass and the migrant labor that's manicuring these lawns and the poisons and herbicides, and he just didn't believe in anything that had to do with an environmental message. And we just fought and fought and fought. We loved each other more than I could ever think of, but we were two sides of a very different America. And so, he passed away 10 years ago of old age, I guess, more or less. But, I just think it's a generational thing, that it's a personal thing. For me, it's super personal, how to get this right. And I'm constantly questioning what it even means to be a designer of any kind, and what can we do to change that. Trained in the 90s, it was nothing to do with social justice or environment or community. That was, if you put a solar panel on your building, you'd fail out of architecture studio. It was like, whoa. So that's all I want to do. And maybe that's just, it's just where we're at now. And then I don't know what's going to happen later, but I think that that's part of the future, is understanding this complete merger between all of design and biology.
I want to think about where we are in our institutions. I tend to think of the people here sitting on this panel. In some sense, you're misfits from the administration under which you work. And I think you're probably fighting a battle to make this part of what they believe in, or make a battle for what you believe in, sorry. I'll just pose this to the whole group. What is the fight, and how are you making the good fight?
You're going for it, Dan, huh? You're really putting us on the spot.
They're recording this, right?
It's all recorded and will be sent to your bosses.
I guess that's what makes tenure a beautiful thing. They can't fire you. I guess they could find a way. I think it's how are we making it happen, or how are we fighting our administrators? Let's say, how are we making it happen? It's a nicer.
They're one and the same, aren't they?
Well, I think, from my point of view, you find, every single person in this panel is a total inspiration for me. I follow the work, and it's just like brain candy. And I think knowing that there's a bunch of misfits out there that are pretty willing to get together and build something bigger. And then when we were talking about the transdisciplinary collaboration, I think there's a certain humility in this. Humans mess this all up, right? We created these problems, so we should check ourselves, but we also can fix them, because the human enterprise is fairly extraordinary thing. And so I think that I look forward to finding those really transdisciplinary communities to fix the problems that were started, because the problems weren't listen, there were lobbyists that always knew plastics weren't recyclable and all that, but it also did seem like a better living, a better quality of life, and now we know that was really short-sighted, and it wasn't really thought out about how these materials, everyone can have a refrigerator for cheap, and then, CFCs. I think that there was just a blank space. There was a blind spot for these materials, or people didn't care, I don't know, or lack of education. And I really see the power of education and community to just do, you're just gonna do on your own what the institution won't support you to do, and be so successful at it that they are suddenly posting your awards. That's what you just do. You just do it anyway, and then they come around because they can't publicly throw rocks at you.
Yet.
I hope no one is here from FIT. Sorry.
In some ways it feels like you've all been going your own route. Can you just talk about what it is you're doing? I see it in the student projects that you're showing, and of course in your own projects. How does it manifest? How do you create the space to do these new types of innovative education programs in your classrooms?
I just kind of do it. I'm an adjunct, but I have a certain amount of rank, so I can kind of build that a little bit. But I think when you were talking about reticence, I think for me, in the sort of industrial design space, I think, which is different than architecture or other design spaces, because what I hear from my colleagues a lot of time is just this unfounded sense of fear. Whatever I'm doing, they're sort of they're very worried that you can't get past the puck, right? The little sort of sample of material. And they really feel that the role of what we do is to spec materials that come to us from chemists. And so it's been my effort to kind of educate people around us to say, like, no, there's some really great things that our students can learn and we as designers can learn by playing in this space over here. And I think a transdisciplinary it has really like prefaced for me, just kind of understanding how to, that I don't have to know everything, but I can bring people towards them as competencies. But I think ultimately, I mean, maybe over time, but I think ultimately this is driving up from students now.
Yeah, I mean, the students
That's
are amazing.
really powerful. Like I have one student who's, she had
students are
already worked with
amazing.
mycelium. She came in, she did the photovoltaics, right? She was like already like on the research, right? So all I have to do is kind of shepherd her and, oh, do this experiment, try this, test it out. We do a lot of testing. That's a big convincer to my colleagues, is to be able to, like that lamp that I talked about, and say like, that's still surviving 3 years out. That's huge, right? So I do a lot of that, like proof of concept, proof of concept, proof of concept. And then doing that has helped kind of the students build the stories.
But the students, I mean, you're just moving, all we do is, I think, move barriers for them.
Yeah.
They do it. I mean, they're amazing.
Yeah.
And they care in a way, they just care, they're passionate, they're sick of it, and you just kind of move things out of their way, and they shoot, they're like rockets.
Yeah.
I think that's actually a good way to close. Yeah, move the obstacles out of the way, and they will shoot like rockets. Do you want to do questions from the audience? Can we do some, if anyone has questions, we have about 5 minutes, so just pop up a hand. Yes?
Can you hear me? Okay, Kate McDonough, Associates. I actually was on a thesis project with a group that studied architecture and environmental engineering. So I'm so grateful. I've cited each of you before. Your work is incredible. In the construction, architecture, and development world, what can we buy, who can we work with now in an economically viable way? I think this is, all of these PowerPoints are really future looking, but what are the products that we can integrate now?
But we have on our website, healthmaterials.org, a list of materials collections that have all been embedded, transparency in terms of their chemical content, their performance, and also have been installed by others. So you can just go there and you can go through. They're divided into the common building products, so resilient flooring, paints. You can make transformations right now in your practice. They have a yellow dot when they're being in affordable housing so that you know that they're affordable. But I just throw away vinyl, never use vinyl. Nobody should ever use vinyl, luxury vinyl tile. The worst product in the entire universe. So you can start like simple steps like that for the general kind of population, but for an architect, interior designer, you should just check out our resources. And then we have links to everybody else's resources too.
Yeah, I mean, we think about this all the time, and it's a very real question. We could probably spend a couple of hours on it, but I think the core is educating your client. You have to get them on board with not only what the added value is and the bottom line for some of these materials and substances, but what it means for them in the building that they would like to produce, and what the kind of the long-term goals they would like to engage in, and give them a lot of the facts. Like it's just, but at the end of the day, they're going to make the decision on whether they want a bamboo floor or vinyl. And most of us have been there when that decision rolls over and they just can't afford to do something in bamboo, or they're not sure that bamboo can be guaranteed for 30 years before it needs to be replaced, et cetera. And that's just bamboo or mycelium insulation. Even in a recent house I did, there's just nobody in Home Depot has mycelium insulation. And you can ask those guys.
IL-42.
IL-42. Bay 3, yeah, exactly.
Just see over there.
Next to the
There's
acetobacter.
no IL-42.
My dream is that one day it's a readily available product like that, and maybe we're not even thinking of an economic system that gets bought and sold like the products we do at Home Depot, but I think it's real conversations with clients, site visits, showing them the materials tangibly, getting them to engage, and showing where they can work, and convincing them maybe 5% of the budget, and this sucks, by the way, but I'm being a realist with you, 5% of the budget can go to something experimental or it hasn't been tested yet, and that still is important. More of this happening, some kind of biotech in a building where there's examples for people to see it, then eventually more people come on board. But it takes years for architecture to change. I mean, you don't replace a boiler for 40 years until it breaks. You don't replace a roof until it leaks. So it's a long conversation, and I think you have a lot of support on your side to do that. And I wish it could be 100%. We're going for the 100% thing, but yeah. It's a different animal, but yeah.
A very like unsexy interjection on this is like there's also a ton of materials that already exist that are perfectly usable, and you're not going to do better. So all these biomaterials, everyone's excited about next gen materials. We're obviously all excited about next gen materials, and we're displacing the more toxic conventional counterparts. But there's a lot of community groups, the grassroots, big reuse, where you can get reclaimed wood, but like huge planks of it. And I think a network of that, and so if you can offset your impact 40% because you used 40% reclaimed materials that are really good quality wood, that's also not to be underestimated, right? Or can you, have a design that's minimal and uses 20% less minimal, then your carbon footprint drops 20%. So I think there's also sort of lower hanging fruit until some of these technologies are more commercially available.
Yeah, changing the design process is really important. We're used in architecture to have everything in every single color and to imagine that every surface has to be covered with something. And so really reducing your palette, reducing the number of materials you use and being very careful with the materials you choose. But the client thing is really important. Having that conversation, that education with the client is hugely important. Like, do you want to poison the people who will be living in this building, or would you like them to live in a healthier space?
If you care.
If you care. Are there any other questions? We'll take one more. Yes.
Yeah, I mean, tech transfer I think that's part of this community building, right? We're trying to find pipelines and start those partnerships that are fair and equitable from academia to, and because there are a number of accelerators, but they're not always very nice. And they're not always like very student, you have new students coming out. It's like, sure, we'll take most of your company for $50,000. And, so I think that's part of this community building and part of events like this, where it's like people are coming in from a VC world, academics, and then the tech transfer office. Can we create pipelines? And I think I see that growing, and I'm really most excited about that because that's how you're going to have impact, is when you can take a thing to market and be supported at each stage of development. So I would say, hopefully some conversations networking here, but also just connecting with some of the universities you see these innovations coming out with. They're pretty open to partnering, I think, in a lot of ways, because everyone wants to see this go to marketplace.
Yeah, I mean, some of us are still in this honeymoon stage where this is all blue ocean and it's super exciting, so much room for invention, ideation, making, getting together and doing something that hasn't been done before. There is a lot of that, and that's a really good thing. So we have this philosophy that sharing and allowing others to come on board since the beginning has always been the point. We don't do that to IP, grab it and own it per se. And we try as much to be as open as possible and as transparent as possible. And I often make an analogy to rap and house music. If we didn't have the Sugar Hill Gang in New Jersey inventing this new form of music where they were completely open, sharing their ideas about rap with others to allow other bands and groups to copy, mimic, remake, reinterpret, do it again, you wouldn't have a whole group of people making a new direction in a whole musical genre. So I think that's still the attitude, and there's those that want to kind of end the research and make it into something that's productized and available everywhere, and that's still super important. We're in this in-between stage from, I guess, first-gen biodesigners to second, but I think the openness has to still be there. If we're like angry wolves, not sharing anything with anybody, we're going to get nowhere. So just positive vibes as much as possible.
Thank you, everyone.
That's awesome.
That's great.
Leave on that.
Positive vibes.
Yeah.
Positive vibes.
Thank you. Thanks, Nancy, for having us up
Yeah,
here.
no, this has been a great